Welcome. We're going to graph a few rational functions. First one, y equals 3 divided by x minus 1 plus 2. Vertical asymptote, just set your denominator equal to 0. So x minus 1 equals 0. Add 1 to both sides. X equals 1 is the vertical asymptote. So let's graph that. The horizontal asymptote is what's added to the whole function, so y equals 2 is the horizontal asymptote. As a reminder, x equals a number is a vertical line, y equals a number is a horizontal line. Right? And that's as good, I guess, as I'm going to get on my horizontal line right over here. Maybe I'll erase that little piece of it. All right, so let's find some points. Let's start off with the x and y intercepts. Find the y-intercept, just plug in 0 for x. So we have f of 0 is 3 divided by 0 minus 1 plus 2. That would give us negative 3 plus 2 or negative 1. So the y-intercept is 0, negative 1. Right, and I'm going to write next to that y-intercept. Maybe I'll box it. X-intercept, we just set the whole set y equal to 0. So 0 equals 3 divided by x minus 1 plus 2. Let's subtract 2 from both sides. So negative 2 equals 3 divided by x minus 1, cross multiply. So we have negative 2 times x minus 1 equals 3 times 1. Distribute the negative, negative 2x plus 2 equals 3. Subtract 2 from both sides, negative 2x equals 1, and then divide by negative 2, x is negative 1/2. So negative 1/2, 0 is the x-intercept. We need at least 2 points on either side of the vertical asymptote. We've already got 2. Let's see what are the ones I want to use. You can plug in any value you want, except for the vertical asymptote. But if I can think of a number that's going to give me a friendly y value, I try to come up with those whenever possible. I'm going to plug in negative 2. So then I would have 3 divided by negative 2 minus 1 plus 2. That would be, so that'd be 3 divided by negative 3 plus 2. That'd be negative 1 plus 2, which is 1. All right, so now let's plug in a next number. All right, we'll plug in negative 1. No, I'll plug in 0, and we know what 0 is. Right? When we plugged in 0, we got negative 1. That was the y-intercept. All right, and then let's plug in 2. All right, so that would be 3 divided by 2 minus 1. Plus 2. So that's 3 divided by 1, which is just 3, plus 2 is 5. And I'm going to plug in 4. I like 4. Right? And so that would be 3 divided by 4 minus 1 plus 2. So 3 divided by 3 plus 2. That would be 1 plus 2 or 3. I have to move that over a little bit. And then don't forget, we also, I probably should have plugged this in already, the x-intercept. And if I wanted to be in chronological order here, it'd go right there. Negative 1/2, 0. So let's graph those points. Negative 2, 1. And negative 1/2, 0. And 0, negative 1. So I got 3 points on the left-hand side. And then to the right, 2, 5. And 4, 3. Right, so there is 2 points. And to the right-hand side, and you know that's an awful lot of blue on that graph. Maybe I should change the color so you can see that better. Oh, orange. I don't usually get to do orange. Right, and then end behavior. So let's write in the end behavior. Right, so f of x going to approach the horizontal asymptote, so approaches 2 as x approaches negative infinity, f of x approaches negative infinity as x approaches the vertical asymptote, which is 1 from the left-hand side. It approaches positive infinity as x approaches 1 from the right-hand side. And then, of course, horizontal asymptote, f of x approaches 2 as x approaches infinity. Right? So that's the official definition of a horizontal asymptote, is a number that the function approaches as x approaches positive or negative infinity. The last thing we're going to fill in is domain and range. The domain is everything but the vertical asymptote. The range is everything but the horizontal asymptote. And this one's done. Let's graph the next one. Oh, by the way, follow along in your notes, and whatever ones are in your notes, graph those. Here we have, I think it might be this one. We have y equals negative 6 divided by x minus 3 plus 2. Vertical asymptote, set the denominator equal to 0. So x equals 3 is the vertical asymptote. Maybe I'll put the equation underneath it. Right? Horizontal asymptote is what is added to the function. So y equals 2 is the horizontal asymptote. So we'll graph that. Right? And then let's find the x and y intercepts. All right, so y-intercept is just f of 0. So that's going to be negative 6 divided by 0 minus 3 plus 2. That would be, it's a bit messy, but I think you can see it. So that would be negative 6 divided by negative 3 plus 2. Negative 6 divided by 3 is 2. So 2 plus 2 is 4. So we have the y-intercept is 0, 4. X-intercept, just set the whole thing equal to 0. So set y equal to 0. All right, so we have 0 equals negative 6 divided by x minus 3 plus 2. Subtract 2 from both sides. So that would be negative 2 equals negative 6 divided by x minus 3. Right, so now we can cross multiply, but we can also reduce. Notice that we can reduce within, when you have a proportion, right, when you have an equation with fractions on both sides, and a rational equation to solve. You can reduce within a numerator, you can reduce within a denominator, or you can reduce within a fraction. That's it. You just can't cross-reduce. So this function could be reduced within the numerator. Both negative 2 and negative 6 are divisible by negative 2. So that would be 1 divided by 1 equals. And if we divide negative 6 by negative 2, that would be 3. And then divided by x minus 3. Now you get the same answer if you don't reduce, but you do have smaller numbers if you reduce. All right, so now let's cross multiply. So that would be 1 times x minus 3, or just x minus 3, equals 3 times 1, which is just 3. Add 3 to both sides, and x equals 6. So that is the x-intercept. So I'm going to write next to the 2 points there, y-intercept, and I'll box that, and x-intercept, and I'll box that. Let's get our points. All right, so I'm going to plug in, and this one has lots and lots of nice, pretty points. So I'm going to plug in negative 3, negative 6 divided by negative 3 minus 3 plus 2. That would be negative 6 divided by negative 6. That's just 1 plus 2 is 3. And I'm going to use 0, which is the y-intercept, so 0, 4. And I'm going to plug in 1. So that would be negative 6 divided by 1 minus 3 plus 2. So that would be negative 6 divided by negative 2 plus 2. So that would be 3 plus 2, or 5. And how about 2? See, I told you lots of points. So I already have 4 points on the left-hand side. Negative 6 divided by 2 minus 3 plus 2. So that would be negative 6 divided by negative 1 plus 2. So 6 plus 2 is 8. And then, of course, you can't use 3, but you can use 4. Right, so now we're on the right-hand side. negative 6 divided by 4 minus 3 plus 2. That would be negative 6 divided by 1. So that's negative 6 plus 2. That's going to be negative 4. I'm a little short of space over here. And, of course, I could always move the domain and range, couldn't I? I don't need that much space for domain and range. And then let's plug in 6. That's a nice number. Of course, we know what happens if we plug in 6. That's the x-intercept. We'd get 0. I'm going to plug in one more. I'm going to plug in 9. So negative 6 divided by 9 minus 3 plus 2. All right, so that would be negative 6 divided by 6 plus 2. So that's going to be negative 1 plus 2. That's negative 1. All right, so we'll graph these. All right, and so you have negative 3, 3. And 0, 4. And 1, 5. And 2, 8. All right, so all those points on the left-hand side. Oops, that one's a little off. And I oriented the board. So let's connect those. On the right-hand side, we have 4, negative 4. There we go. And 6, 0. Actually, I could have plugged in 5, too. 5 would have given us a nice point, nice pretty point to graph. Just for the heck of it, I'll write in 5. So one extra point I'll throw in there. If I plugged in 5, that would be negative 6 divided by 5 minus 3 plus 2. That'd be negative 6 divided by 2, which would be negative 3. And negative 3 plus 1 is a negative 1. So if you want another point, there's another point. Right? So that's the point, 5, negative 1. Just in case you didn't think we graphed enough points. I'd write it in on the the table there, but I ran out of space. And then finally, 9, negative 1. Excuse me, 9, that says negative 1. Excuse me, that's 9, positive 1. Since when is 2 minus 1 negative 1? Positive 1. So if you get a funky number, it's not matching the rest of your graph, just take a look and see you didn't write down the wrong number. And there we go. And I'll just put next to this one, extra point. Oh, it's not very pretty. You couldn't read it anyway. You know what? Maybe we'll just throw the point in the graph someplace. Or in the table, excuse me, someplace. Now look what happened. It's really hard to figure out where my writing is going to end up sometimes. All right, I'll squeeze that point in somewhere. If I move this up and this up, there we go. So I'm just going to squeeze in the last point we graphed, and that was 5, negative 1. There we go. And all we need to do now is the end behavior and domain and range. Right? So I'll put the end behavior, I guess, over here because this is the easiest place on the board to write. Right? So f of x is going to approach the asymptote. So that would be approaches 2 as x approaches negative infinity. It approaches positive infinity as x approaches the vertical asymptote, which is 3 from the left-hand side. Function approaches negative infinity as x approaches 3 from the right-hand side. And then the function is going to approach, of course, the asymptote as x approaches infinity. Last things, domain and range. Oops. I guess I could write in black. I choose purple. Domain is everything but the vertical asymptote. So negative infinity to 3, 3 to infinity. And the range is everything but the the horizontal asymptote. So negative infinity to 2, union or and, 2 to infinity. And there we go. Another one is graphed. Right. Let's graph one more. Right, so we'll graph this one. We have y equals 3 divided by x minus 4 minus 2. Vertical asymptote, just set the denominator equal to 0, so x minus 4 equals 0, x equals 4 is the vertical asymptote. Horizontal asymptote is what's added to the whole function, so y equals negative 2. And then we will find the x and y intercepts. Maybe I should write over here. Hopefully I can write over here. And so I'll plug in 0 for x. Oh no, what was I thinking? What was I thinking? I can't write over there. I'll have to put it over here. Maybe I can put it over here and move it over. All right, so the y-intercept will plug in 0 for x. That would be 3 divided by 0 minus 4 minus 2. So that is negative 3/4. 2 is 8/4. So that's going to be negative 11/4. So the point 0, negative 11/4 is the y-intercept. Let's see if I can't move that over. I can move that piece over. How about the rest? Yes, that's going to come all together. Isn't that nice? Let's find the x-intercept by plugging in 0 for y. So 0 equals 3 divided by x minus 4 minus 2. Add 2 to both sides. That's 2 equals 3 divided by x minus 4. We can cross multiply. So we have 3 times 1 equals 2 times x minus 4. 3 times 1, of course, is just 3. Distribute the 2, so that would be 2x minus 8. And then subtract, add 8 to both sides. So 11 equals 2x. Divide by 2, 11 halves is the x-intercept. So that would be the point 11 halves 0 is the x-intercept. Let's bring all of that over because it's right in the middle of my graph. Here comes half. Whoop. Here comes the other half. Oh. Here comes the bottom. Here comes the other half. All right, here comes part of it. Obviously, we're going to move over piece by piece by piece. How about now? No, still not the rest of it. That's everybody. All right, so we have, and that's the x-intercept. Hopefully I don't need that portion of the graph anymore. So y-intercept, why did I even try? That was supposed to be a box. No, go away. We'll get rid of you. Get rid of you. Cut. There we go. Okay. We're done with that part of the problem. Let's find our points. All right, so we need to plug in at least 2 on either side. I choose 3. 3 would be a nice point to choose. And we need another one. How about, oh, we already have we have 0, negative 11/4. That's on the left-hand side of the graph. That's a nice point. Well, that's an okay point, but it's one we have to graph. Let's just plug in the 3. And it's good enough. All right, so we have 3 divided by 3 minus 4 minus 2. And that would be 3 divided by negative 1 minus 2. So negative 3 minus 2 is negative 5. If I can find more pretty points, I graph in more pretty points. If all I'm going to find is 1, or 2, I have to have 2, then, maybe 2 is all I'm going to graph. 5, 3 divided by 5 minus 4 minus 2 would be 3 minus 2, so that's going to be 1. And then we have the x-intercept, 11 halves 0. And I think that will be, oh, let's plug in 7. 7. I like 7. 3 divided by 7 minus 4 minus 2. That's 3 divided by 3. That's 1 minus 2, or negative 1. So we'll graph those points. Right, so that's going to be 0, negative 11 fourths. So that would be the same as 3 1/4. So that's going to be below here. Right, about, oh, excuse me, not 3 1/4. That's going to be 2 3/4. What was I saying? So right there. And then I plugged in 3. Oh, I could have plugged in 1. 1's a pretty point. Since there's one more pretty point, I'll plug that one in. So 1 would be 3 divided by 1 minus 4. That's going to be 3 over 3 plus, or minus 2. Don't forget the minus 2. So that's 3 minus 3. 3 divided by negative 3, that's negative 1 minus 2, that's negative 3. We'll squeeze that one in. So let's graph that point as well. So we got 1, negative 3. And then I plugged in 3, and I got negative 5. So this is what the left-hand side of the graph looks like. Right-hand side, we got 5, 1, 11 halves, 0, so that's 5 1/2, and 7, negative 1. So there is the right-hand side of the graph. Come on. Come on, you've been doing so well, board. You can do it. I'm afraid to put the pen down. Come on. You think it's coming? Should I do it again? Come on. I don't see a spinning ball of death, but somewhere there must be a spinning ball of death. I will put the board pen down. Come on. Any day now. We got one last thing. Domain and range and end behavior. Okay, 2 last things. And one little piece of the graph. Don't make me re-record this. I'm sorry. Students, I have no idea what's happened. I don't see a spinning ball of death anywhere. Well, you know what? I may have to stop this tape right now and come back, and I'll finish the rest of the graph. I think that's what I'll do. All right, well, we'll finish this one in the next video, and we'll do one more problem. Thanks for watching. Sorry for the glitch at the end here. Bye for now.